And so after this, I want to start word problems already. So um, we'll have explored. So I'm just going to call this overview of all the functions. So the first one is our linear. What's the degree of a linear? Just 1, right? Yeah. Page 22, guys. And the equation looks like this. Page 22. AX plus B. Okay, so what do we know about this? That one right there is called our leading coefficient. I'm going to call that LC moving forward, right? And the leading coefficient tells us a lot, okay? It tells us the direction and therefore the end behavior. And it also tells us, this one is less important, but I do think that you should know about this. It tells us how steep it's going to be. I'm just going to call it the steepness of the line. It tells us that. Okay. So how do we know direction? If the leading coefficient is positive, okay, this line is going to go up from left to right. If the leading coefficient is negative, we expect it to drop. And steepness, if I would say if A is greater than 1, it will be very steep like this. If A is between 0 and 1, it's going to be a shallower, not as steep kind of curve. Okay. All right. So that's that part. What does the this one do? B. It's our y-intercept. It is the y-intercept, but it is also, watch this, it's going to result in a vertical shift. What's vertical? Vertical is up and down. So if you were to increase this, the whole line will shift up. If you were to decrease this, the whole line will shift down. It doesn't matter which way it's pointing. It's going to be shifting vertically if you were to change that. And in grade 11 applied, we did questions where I said, hey, come up with an equation where the maximum height would be, 3 feet taller or higher. So what you needed to do is to just change that by 3, right? Up 3. If you want to lower it, then you got to go, right, 3 lower than this, like decrease this by 3. So that's what that does. So then we get into our quadratic functions. These ones have a degree of 2. The graph is actually called a parabola. So if you at all get a sense of, hey, the path of this projectile has a parabolic shape, oh, parabolic, that's parabola, that is quadratic. That's a quadratic function. So a quadratic, the equation or the function looks like this, where B and C may be 0, as long as A isn't 0, it's still a quadratic. Okay, so this one right here, that is what we call the leading coefficient. And it also tells us 2 things. Okay, it tells us the direction of the opening. So if the LC is positive, we know that the legs are going to be pointing up. If LC is negative, the legs are going to be pointing down. It also, it is related to steepness, but I would say it's more the width. if A is greater than 1, it's narrow. The greater A is, the narrower the legs, the closer together the legs will be. Okay? And if you have A being between 0 and 1, it's going to be a wider curve. So the smaller, like if it's 0.0003, that's going to be a really, like you can almost imagine it's going to do like something like this. Versus narrow, you're expecting the legs to be closer together in general. Okay. So that's what that does. What else do I have to say about this one? Oh, a parabola is symmetric, very important. We're going to make use of symmetry. And if you were in grade 11, you know what I'm talking about, right? You can, whatever happens in the first half happens on the second half on the way down, or vice versa on the way up. Okay. Very important, symmetric. Something else I wanted to say, of course, about the C value right here. It gives us the y-intercept. It tells us what the coordinate of the y-intercept is just by looking at that number. And it also results in a vertical shift. So all of the polynomials, like the linear, quadratic, and cubic, the last one gives us the y-intercept, and it also will determine if you were to change it, if you were to increase it, the whole thing would go up, or the whole thing would go down if you were to decrease it. So that stays the same. If it's a quadratic and a positive leading coefficient, what's the end behavior? This is Q2 to Q1, right? So those are things that I will ask you shortly. Last one is cubic. A cubic function has a degree of 3, and it's most known for, it does some sort of a wave. It's like an S shape, right, to a certain degree, and it's not necessarily symmetric. That's what I'm going to say here, and it happens when you see something on the equation, on the function. So here you go. This is in general. Notice that this could be f of x, h of t. It could be anything, but it's still our y variable, right? So this would be ax cubed plus bx squared plus cx plus d. So they all get like progressively longer, but really we always focus on that the value in front of the highest power. So this is my leading coefficient. It still tells me the direction. Okay. If LC is positive, we know it's going to do this. Which one does this behave similar to? Linear, right? Because it has the same, it's odd exponents, so they have the same end behavior. If it's a negative leading coefficient, it's the same as a linear. So imagine a linear function, and so just make that little s instead of a straight line. Okay. And it also affects the steepness. I will just say, just like before, it affects the steepness. I'm just going to leave it at that. That's not as important to me as the other ones. Or should I? You know what? It doesn't hurt. If A is greater than 1, it's going to be more like vertical like this. If A is between 0 and 1, it's going to be a little bit more like almost as if it's laying down sideways. You know what I mean? It's going to be a bit flatter like this instead of vertical. So it's kind of like the same as your linear function in that sense. Here is where I want to add, some of you were asking me yesterday, does this thing have a turn? And I will just say this. If either one of these is present, so x squared or x, it will have a turn. Okay? If present, there is a turn. there are two turns, sorry. There's either 0, there's either 0 or 2, right? So if those are there, 2 turns. If they're not there, how many turns? 0. Okay, so it's implying, I hope that you get that. If you need to write that down, if not, no turns, right? And then this one, guess what? It's still going to be, it's going to give us the y-intercept, and it's also going to result in a vertical shift. So lots of similarities, but there are different nuances with both of them, with all three, I should say. So y-intercept vertical shift still happens, and it's observed when you make changes to that. Furthermore to this, if you have a turn, it turns asymmetric. Meaning there's no way you can cut this thing in half and get two same halves. Okay, that's what that means. All right, I think we're good to go now. That's all I had in mind. I wanted to give you this one more time before we dive into word problems. So I'll stop here.